lesson is over percent. It's like a mixture of given the part, find the percent, given the percent, find the whole, find the part. So you'll see through our lesson. So let's look at our do now. Chen wants to buy a pair of pants that regularly cost $50. Today, the pants are on sale for 60% of the original price. How much will he save? So you could draw a percent bar, or you can use the percent proportion of part to whole, which is percent per 100. So we know that it's 60% off. The whole price was 50 bucks. How do you break it down from 100 to 50? Divide by 2. Divide by 2. So I get 30 over 50. So the part that he will save is $30. So how much will Chen have to pay for the pants? If it was $50 and you save $30, he will pay $20. Another way to do it is this way. Well, we know he will save 60%. That means he will have to pay 40% of the original price. So you can break it down, and then you have gotten 20 exactly. But I wanted to show you how much he's going to save. What's his discount? Then you take it away from the original price. So $20 is how much he will pay for these shorts. But the saving was $30. So imagine you're at a restaurant and your bill came out to be $32. If you leave an $8 tip because of the quality service, what percent did you leave behind for the server? Many ways you could do this. You could draw a percent bar. So we don't know what the original price is. But we do know we left an $8 tip. So 50% goes right here. Oh, I'm sorry. Let's go back to it again. I'm sorry. The original price, the total price was $32. It goes right here. Many ways you can break this down. We could break it into by 50%. That'd be $16 right here. But if it's $8 tip, which is halfway between 0 and $16, what percent is halfway between 0 and 50%? So we left 25% tip, or $8. Or maybe we prefer the percent proportion, part to whole, percent per 100. So what part did we leave behind? $8. The whole price was $32. Let's find the percent. Can 32 be scaled up to 100? I don't think so. We're going to have to break this down. So we divide by, let's divide by 4. That would be 2 over 8. I could break it down again, divide by 2, 1/4. Now, can we scale it up? How many 4s go in 100? Times 25, times 25. 25% is the tip amount. That's like really good service, by the way. Every month, I get a haircut. I get it on Mason Road next to Las Mañanitas. It costs $5 per haircut. Actually, it really is $3.99. But which is, I don't know. Sometimes it's, I don't know. Yeah, it's actually $3.99. Or is it $4.99? Can't remember. So, if Mr. Joe leaves a $1 tip, what percent did he tip the hairstylist? I am such a big tipper. It costs $5 for this haircut. I leave a $1 tip. So $1 goes somewhere here. $1, $2, $3, $4. So what should I break this down? It seems like it's breaking it down into 5 parts. So 100% broken into 5 parts is 20%, 40%, 60%, 80%. So if I leave a $1 tip, I just left a 20% tip. Maybe you don't like using a percent bar. Maybe you rather prefer to use a percent proportion. So what part did I leave behind? $1. The whole price was $5. what percent did I tip her or him? I multiply it by, scale it up by 20, I get 20% tip. That's really generous of me. You know, sometimes I think to myself, if it was a $4.99 haircut, if I give them $5 and don't tip them, will they hand me back a penny? The memory card or Melcher's digital camera can hold about 400 pictures. Melcher took 96 pictures. What percent of memory card did she use? So there are 400 pictures. She took 96 pictures, which should go, well, I know 200 is right here, that's 50%. 100 would go right here, that's 25%. So 96 would go right here. If I had to take a guess, I think it's about 24%. But let's use the percent proportion just to be sure. Parts to the whole. So part of the picture she took was 96, the whole, all the picture were 400. How do you scale it down? You divide by 4, divide by 4. 96 divided by 4. Is it a 24? It is 24%. So 25% of the camera hold her 96 pictures. So let's practice some more. A pair of jeans, let's make it a little harder now. Now we're going to be given the percent now. And you're going to give the whole. Can you go back and find a part? A pair of jeans is on sale for 20% off the original price. If the regular price is $42, what is the amount of the discount? Amount of the discount. So I'm going to use percent proportion here. The regular price, isn't that the whole price? That's $42. It is on sale for 20% off. So 20% goes right here. So I want to find what part of it do I save. So can 100 go to 42? So we need to break this down. So I break this down by dividing by 10. I get 2/10. So if you simplify this again, you get 1/5 is not going to go in here as a whole number. But however, it can go in as a decimal. So how can I build up from 10 to 42? I build it up by 4.2. I build it up by 4.2 because 42 divided by 10 goes in 4 times. It's 4.2. So 2 times 4.2 is 8.4 or $8.40. So 20% of $42 is $8.40. Another way to think about it is using a percent bar. I could have broken this by 10%. I'm not sure why I did 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So if you have $42 and you to break it into 10 parts, each part would have been $4.20, 10%. So another $4.20 will be $8.40 or 20%. So the savings will be $8.40. 40% of the class is wearing a jacket. Blah. Not a little less than half. If there are 25 students in the class, how many are wearing a jacket? Couple ways you can do this. You can break it into 10%, 10, 20, 30, 40, 50, 60, 70, 80, 90. So if you break 25 students into 10 groups, there's 2.5. 2.5 is 5. 2.5 is 7.5. 2.5, add 2.5, the skip count is 10. 10 students will be wearing a jacket because you cannot have a decimal of a student wearing a jacket. What if you do not like using the percent bar? Maybe you prefer using the percent proportion. What part of the class? We don't know. We know there are 25 students in whole and 40% are wearing a jacket. So can you break this down? I can break it down by 10 and I get 4/10. I break it down by 2, I get 2/5, and I scale back up by 5, I get 10 students. Another way, I'm thinking what I should have done is, maybe I should have broken it, no, it's good. No, I could have broken it down to 20 over 50, and 10 over 25. If I had simplified this to 10/25, I would have gotten my 10 right there. So what part of the class is wearing a jacket? 10. Next one. Alicia has saved 60% of the cost of a new cell phone. If she saved $105, what is the full price of the cell phone? I want to find right here. So I'm going to use the percent proportion. The full price is $105. Part of her saving, we don't know, 6%. What is the, oh, sorry, I misread it. So again, if she say 105, is that part of what she, yes, that's part. Find the full price, which is the original whole price. So we don't know this part. So can 60 be built up to 105? No, we're going to have to simplify this now. I divide by 2, so I get 30 over 50. Can it go into 105? No, I had to break it down again by, I divide by 5, or I can divide by 10. That's 6 over 10. And I can break it down again, I get 3/5. Now, can I build it back up to 105? What do I multiply 3 by to get 105? Let's see. That's 3 times. I multiply by 35. So the full price, 5 times 35, is $175. It's the full price. Again, you can, so the original price is $175. Item 4, 15 students on the debate team stayed after school to practice. If 33 and 1/3% of the debate team stayed after school to practice, how many students in all are in the debate team? Let's think. So every 33 and 1/3% is 15. Another 33, 1/3 is 66 and 2/3%. That would be 30. So 1/3, 2/3, 3/3. So 15, 30, 45 is the answer. And next one. If 30% of the students in the choir are 7th graders and there are 27 7th graders in the choir, determine the number of students in the choir. That's everybody. It's a whole part. So what do you want to use? I don't care. Do you want to use the percent bar or do you would like to use the percent proportion? I really don't care. Well, let's use this one. This is right here. 30%. I know 27 7th graders. That's part of the choir, but we don't know what the full amount of choir is. Let's break this down. We'll break it down by 10. That's 3/10. Build it back up to 27 by 9. So there are 90 students in the full choir. So what we're pretty much doing right now is using the percent proportion or percent bar to find the parts, the wholes, the percent. Using that, you'll be able to answer all these questions, anything with percents.